friends, I am Elias, Assistant Professor in Civil Engineering Department, Sandipani Technical Campus, Lect. And topic is analysis of the pin-jointed indeterminate frame subjected to settlement of support by Castigliano's theorem or a principle of minimum energy. Learning outcomes. A student will be able to understand the steps of analysis by Castigliano's theorem, and also student will be able to analyze the indeterminate pin-jointed frame subjected to settlement of support. This is our numeric. The support C of the truss settled down by 3 mm. Find the support reactions and member forces in the truss due to this settlement. All the members of the truss have the same cross-section area 2000 mm square and modulus of elasticity E is 210 kN per mm square. Support B is the hinge support and support C and support D are the roller supports. So first step is the calculation of D.S.I, that is degree of static indeterminacy, that is equal to the external static indeterminacy plus the internal static indeterminacy. So external static indeterminacy is equal to R minus 3. R is the number of reactions. So here RA, RC, RD and HA are the reactions. So R is equal to 4. So 4 minus 3 here, that is equal to the 1. Then next is the internal static indeterminacy, that is equal to M minus in bracket 2J minus 3. Here M is the number of member, that is equal to 5, and J is the number of joint, that is equal to the 4. Now put this value into our formula 5 minus in bracket 2 into 4 minus 3, so that is equal to the 0. So DS total static indeterminacy is equal to 1 plus 0 is equal to the 1. So from this we can conclude that here this frame is externally indeterminate to the 1 degree. Then take a pause and question arise in the mind, what are the different steps of the analysis of frame. So now steps of analysis. Remove the redundant, then calculation of reactions, then the key analysis, then prepare this table member, then area, then L is a length, then P is a force developed in the members due to the external loading, then K is a force developed in the member due to the unit load, then PKL by A and K square L by A. So last here is the summation of PKL by A and summation of K square L by the A. Now this is our basic formula, that is sigma PKL by A plus X summation K square L by A is equal to the delta. This delta is initial joint displacement. If there is no settlement of support, then here this delta is the 0. But in our case, the delta having some value. But sigma PKL by A, this value is the 0 because there is no external loading. So X is equal to minus delta by summation K square L by the A. Since X is the unknown force, or we are treating it as a redundant, then once we got the value of X, the forces in the members are S1, S2, S3 and S4, and here this P1 is the unknown force developed due to the applied load and K1 is the force developed due to the unit load. Then next step is the removal of the redundant. So here this frame is externally indeterminate structure. So here we have to remove the any one reactions. So we are here treating the vertical reaction at RC at C as a redundant. So remove the vertical reaction at C and release the structure. So we are removing here the reactions and releasing the structure. Then apply the unit load at C. So we are applying the unit load at the C. Then the key analysis. Here there is no external loading, that is why P analysis is the 0. Then go for the key analysis. So calculation of the reaction. Sigma MB is equal to 0, clockwise positive and anti-clockwise negative. So 1 into 4 is the clockwise and the 7 into RD is the anti-clockwise. So RD is equal to 0.57. Then apply sigma alpha condition here. RA plus RD minus 1 is equal to 0. RD is equal to 0.57. So here RA is equal to 0.43. Now sigma fx equal to 0. Here and joint B, there is no any other horizontal force, that is why HA is equal to the 0. Then by applying the method of joint and find the member forces in the frame. So first we are considering the joint B and find the force KAB and assume the direction of KAB is toward the joint. This force is inclined, so this is the resolution of the forces. Vertically downward is KAB sin 45 and towards left horizontal is KAB cos 45. So here we are applying the sigma alpha condition. Vertically upward is positive and downward is negative. So here RA is vertically upward, that is positive, and this KAB sin 45 is downward, that is why is minus, and that is equal to the 0. Do you know the value of RA is 0.43? So put here 0.43 minus KAB sin 45 is equal to 0. So KAB is equal to 0.6. Then KBC force here. Then assume the direction of KBC is the away from the joint. So apply here sigma fx condition. Towards right plus and towards left is minus. Then here towards right is KBC, that is why is a plus, and KAB cos 45 is toward the left, and that sign is a minus. That is why is a minus, and that is equal to the 0. We know the value of KAB is 0.6, so put here. So KBC minus 0.6 cos 45 is equal to 0. So KBC is equal to 0.43. Then we go for the joint C here, considering joint C, and member force is the KAC. Now assume the direction of KAC is the away from the joint. Then here we apply here sigma alpha condition. Upward positive and downward negative. So KAC is upward, so that is a positive, and one unit force is downward, so that is a negative. So we can say that KAC is equal to the 1. The next force is the KCD, and assume the direction of KCD is the away from the joint. So now again apply here the sigma fx condition. Towards right plus and towards left is the minus. So KC is towards the right, that is why is a plus, and KBC is toward the left, that is why is a minus, and that is equal to the 0. So put the value of KBC is 0.43. So KCD is equal to 0.43. Then next consider the joint D and find the force KAD. Assume the direction of KAD is towards the joint, and this member is inclined, so resolve this into two forces. Horizontal force is toward the right, and that is KAD cos 53.13, and here vertical force downward KAD sin 53.13. So we are applying here sigma alpha condition. So vertical force upward is RD, and this KAD sin 53.13 is downward, that is why is a minus, and summation is equal to the 0. So put the value of RD 0.57 minus KAD into sin 53.13 is equal to 0. So KAD is 0.71. So here these are the directions and these are the magnitudes. So remember this AB is a compression, AD also is a compression, and remaining three members are in the tension. So BC, CD and the AC are in the tension. Then as per our table, these are the members AB, AC, AD, BC and the CD, and area of the members is same, that is 2000 mm square. Length of the member in the mm. Now here There is a no vertical load or no external load, that is why here this P value is the 0. Then this is the K, that is the force developed in the members due to the unit load, and that are the 0.6, minus 1, 0.71, minus 0.43, minus 0.43, and here we have taken the sign convention as compression force is positive and the tensile force is the negative. And here P is 0, that is why here sigma PKL is 0. Then next column is a K square L by AE. Here K is a 0.6 and that is a square into length of member, then area of the member and the modulus of velocity. So that is 1.01, 2.0, 1.26, 0.36, 0.27. Here the E is the same, that is why I have taken as the denominator. So this value is 4.90 divided by the E. Now, as per our formula, here reaction at C, that is XC, that is equal to minus delta by K square summation delta by summation K square L by the AE. Here XC is equal to minus in bracket minus delta. Why this is minus? Delta taken as negative for the downward settlement. So here the support is the settling down, that is why I take here delta as the negative. So now XC is equal to minus delta is our minus 3 into this equation, previous equation 4 by 9 divided by E. So we go on the numerator. So now here XC is equal to minus in bracket minus 3 into 210, because here E is equal to the 210 kN per mm square. So we got here XC is equal to 128.57 kN. So this is the reaction at the C due to the settlement of the support. This value is positive. It means what we have assumed the settlement is downward, and that is the correct. Once we got the value of XC, then member forces are evaluated like S1, S2, S3 and S4 and so on, where S1 is equal to the P1 plus X into the K1. So P1 is the member force due to the applied load and K1 is the member force due to the unit load. So in our case, this P1 value is the 0, P2 value is 0, P3 is the 0, only is the X into the K1. So here we have prepared the table. These are the members and the force due to applied load, that is a 0 because there is no external loads. Then the K, the force developed in the members due to the unit load. And then here this P value is the 0 because there is no external loads. Only remaining the X into the K. So here X is equal to 128.57 kilonewton. So 128.57 into the K, that is 0.6, that is equal to 77.14. Next is minus 128.57. Then next is 91.28, and same procedure here, minus 55.28, and last also the same, that is minus 55.28. We are considered here compression as positive and the tension as negative. That is why here this positive value is compression and negative value is the tension. Again here positive is compression and this last both values are negative. So these are the considered as a tensile. Thank you.